you guys all drew a... Alright, so let's take a look. Actually I didn't have to draw, I think. So, here's the thing. If you did draw one,
So it's like that?
men, women,
Oh, you just don't know how to do
men, women,
I was like, how did
men, women. So how many men are there? What's probably, you pick a man?
8 out of 25.
8 out of 25. So once you get here, I'm just going to focus on this part here for now. Once you're here, after you picked a man, how many people do you have left?
24.
24. How many of them are men?
7.
Only 7 of them. You have one less person, you have one less man because you picked one already. So already, see what we're talking about? So now, the probability to pick a man is going to be, you only have 7 less left out of 24. Now what's the probability to pick a woman? 17 out of 24. You still have 17 women. So, again, remember we have a couple different problems. So if it's with replacement, then these would stay the same. It's like the cards. Remember when we picked the cards? Probably if the first one draws an ace, it's 1 out of 5. Probably the second person draws an ace. If they replace it, it's still 1 out of 5. But if they keep the card, it changes, depending on what they drew. So when you don't put them back, then it changes things. And you can't win, you can't both win the same award. So here, both men would be 8 out of 25 times 7 out of 24. And this is 0.0933, I think it was. Yes?
Yes.
All right. So what's our guideline for unusual? What's our unusual guideline?
5%.
5% or less. If you're 5% or less, you're unusual. Is this 5% or less? Okay, so one thing to think about is, roll this up so I can reach it better. Okay, so you guys, eyes here. If you have trouble with percents, then everyone is familiar with money, right? Where's the cents place? Where would the pennies go? Right here, everybody on board? So let's cover up the rest of these. So that's about 9 cents. 9%. So 9 point whatever, 9.33%. Does that, you guys kind of follow? That's the easiest way to kind of get from one to the other one. Think of it as 9 cents. So a cent spot, 9 cents, 9 something percent, 9.33%. Or you could also write 5% in a decimal. So here's 5%, 0.05. And you can see that it's less, 5 cents, 5%. If you have trouble comparing these like this, then just give this an extra couple of zeros so they have the same number of decimal places. That one has 4. You could also just give this one 2 more decimal places, right? So that's a little bit easier to wrap your head around. 933 versus 500. So you can do it that way. So you know, so you'd say it's likely because it's not less than 5%. Remember, our guideline for unusual or unlikely is 5% or less. That's statistics. It's not super likely, but it's a little bit likely. It's kind of likely. It doesn't change our. It doesn't pass our test for being unlikely. All right. So earn. This is problem number 2. I think we're going to skip. We'll come back to number 1 in a minute. Let's do problem number 2 first. Earn 1 contains 4 red balls, 1 black. Earn 2 has some stuff. Earn 3 has some stuff. What's going on first? An earn is selected at random. How many options are there? 3. It's at random, so how likely is each one?
1/3.
1/3. Does everybody understand that? It's at random, so they're all equally likely. Now you should figure out, if I picked earn 1, then I could do what? What could I get? I could get a red one, or figure out how that goes. So take a couple minutes to do 2 and 3 if you haven't.